we will introduce you to this essential piece of software that we're going to need throughout the semester. This software is called Jupyter Notebook. It is essentially a graphical interface for us to type text, math, and also allow us to use Python to help us work out some mathematical problems. All right, so this is the environment of a Jupyter Notebook. Once you open it up, it's going to look like this. We will introduce in a separate video about how you can get access to this. But once you open up this software, what you see is it's going to give you a list of the root folders. In this instance, I'm actually running it on my local machine, so it doesn't point to a particular website, although it is running my browser, which is Chrome here. So what I would do when I open up Jupyter Notebook is I would just navigate to the folder where I want to store the files or the notebooks. So in my case, it's going to be called econ260 SimPy here. I already have a bunch of files prepared here, but if I want to create a new file under this folder, I will just click New, and then I'll choose Python 3. Actually, in my machine, I have several instances of Python 3 installed, so I'll just choose this one. If you have only one of them, that's totally fine. Use whichever one you have. All right, now we're in. This is a notebook. And let me zoom in a little bit so you can see it better. And this is a Jupyter Notebook. You can see it's Jupyter. It has, and this is the file name. It's called Untitled1. And I can rename it. Once I click on this name, I'll be able to rename the file. Let's say test econ260. And then I can hit rename. And now I have a Jupyter Notebook that's called test econ260. It's going to tell me when was the file saved. I think from time to time, the program will automatically save the notebook for us so we don't lose too much work. And you can save along the way yourself by hitting the save button or hit Control S or Command S on Mac. So this is it. It looks very much bare bone type of interface. It has a very retro feeling to it, which is why in the beginning when I first saw this kind of interface, I'm like, no, I'm not interested in this. It doesn't look very cool. But in fact, it works surprisingly well for our purposes. So let's take a look at what it does. Okay? A Jupyter Notebook does something very straightforward. You type some code and then the computer does the job. This is why it only has so few buttons on it, precisely because most of the interaction is going to happen through code as opposed to menus and buttons. But we're going to learn the ropes as we go along. So for instance, we can just type in something very arbitrary. Let's say, what is 1 plus 3? So it says in, so this is what you're putting into the system. What is the input to the program? It's just 1 plus 3. And I can hit run, and it's going to tell me the output is 4. That's it. And we can also calculate what is the cube of 3, right? So 3 raised to the power of 3. I can hit run. It's going to tell me the value is 27. So there you go. Now you've had some experience with Jupyter Notebook. It's not that bad at all. It's just a very fancy calculator, if you want to think about it that way. Now let's actually turn to look at a different notebook that I have prepared to help us go through the introduction of the Jupyter Notebook. So I can just close this tab, and it will remind me that changes are made, may not be saved. Now I can actually hit save. So now this file is being saved. It's telling me that a few seconds ago, auto-saved, and I can close it. Now it will return me to this root folder that we were looking at in the beginning. And now you notice that we have a new file here that did not exist before. And also you will notice that this little icon here as a notebook will be green. And on the right hand side, it says it is running. Okay, it says it's modified seconds ago and it is running now. What it means is, although we have closed that tab, but this notebook and the code and the results we got, the 27, etc., are still stored in the live memory in the computer. If you want to end that, you can just make a select this notebook and say shut down. That will clear everything about this notebook from the running memory of your computer. We can still open it again, it's still there, but all the outputs were no longer stored. It will just appear in the notebook, but it's not in the running memory of the computer. If you don't care about that, don't worry about that. But that's the distinction between the green and the gray notebooks. Again, let me shut this down. And in fact, we can also edit our files in here. I can select multiple files, and let's say I don't want to see these files anymore. I don't need them anymore. I can move them. Okay, I can duplicate them, I can edit them, or I can delete them. Let me delete these two files. It's going to remind me whether I want to permanently delete them or not. I'm going to go delete, and there we go. Okay, now you would have deleted the files. But be careful about what you do with the files, because just like when you're operating on the files in a file browser, whatever operations you do here are really being deleted. Okay, now let me open up this file that I already prepared as an introduction to Jupyter Notebook. All right, this is just a Jupyter Notebook where I typed a lot of things into it. The file name is called Intro to Jupyter Notebook, and again, I can change that if I want to, but I'm happy with that now. So first of all, why are we interested in using Jupyter Notebook for this course? Well, the reason is because it is a very unique environment that allows us to type math very easily and nicely, while also allowing it to be shared, across different machines, across different people reasonably easily. And it is relatively easy to learn relative to other things that are sort of more obscure, doing similar things. A second component that's very nice about Jupyter Notebook is, in fact, that it is an environment where you can run Python codes. Okay, and within Python codes, there is a particular set of tools called SymPy, and this library or this toolkit allows us to solve problems symbolically. And we're going to be very specific about what we mean on that. So combining these two aspects, it allows us to write math, describe what we're trying to do, write a lot of text and present them very nicely, while allow us to borrow some tools from the symbolic calculations to make our jobs in algebra a little bit easier. So it is ideal tool for our purposes. In addition to what we use it for in this class, there are some benefits about learning Jupyter Notebook even beyond this course itself. You will see a lot of tutorials of Python and R and these type of programming languages are done in Jupyter Notebook, just because precisely that is very good for documenting things while executing programs side by side. It seems like a lot of things, but for now, you don't need to worry about any of this, and we'll learn the ropes as we go. The expectation is you coming in not knowing any programming at all, and you will realize that what we do really isn't anything very scary at all. And hopefully you'll find it somewhat interesting. As I mentioned already, we'll have a separate video about getting access to Jupyter Notebook. But now let's just turn to take a look at the Jupyter Notebook environment itself. So before we dive into any sort of details about these particular languages, which is all very confusing and intimidating, let's just look at a particular example. Right? So in this example, we want to do something very simple. And by the way, each one of these things is called a cell, right? And in each cell, I typed in some code. For instance, here I typed example, colon, what is the derivative of, $, and then f of x is equal to x raised to the power of 2 minus 4, $. This is some code. But once I select this cell and I ask Jupyter Notebook to run it, what it does is it just renders it into this nicer looking text and looks as if it's part of this web page. Right? But in fact, if I double click it, it's going to return to the code. In other words, what I typed in here are just being rendered into a nicer looking form of text. And that's exactly sort of the type of thing we would want if we are, say, answering questions or typing solutions to a math problem. Now let's look at this cell, the next cell below it, where I typed answer, the derivative is $, a bunch of stuff, which looks a little bit scary now, $. What you will learn later on is, in fact, the $, signs are just markings that tells the code whatever is wrapped between the double dollar signs is an equation. And the equation follows some rules of something called LaTeX that typesets into nice mathematical expressions like this. And because the first line was not wrapped in these double dollar signs, it's just going to be treated as regular text. So let me run this cell now. And see, all that scary notations just render into this nice expression that says the derivative of this particular function f of x with respect to x is the derivative of this function, which is definition of f, with respect to x, and the derivative of that expression is just 2x. That's it. All right. Now in the next cell, I'm writing more text, say that, well, we can calculate this derivative using SymPy, which is the library we introduce you to later on in Python that can help you do some magical stuff. So I'm going to render this file, this cell as well, and now it becomes text. So if you look at everything I wrote above here, it is just one massive file of text, and it's just being rendered into this nice looking text. So in fact, you can edit everything in here. Even this separation line is just 3 stars that is being rendered as Markdown. Okay, and I'll explain what Markdown is in a second, so don't worry about that for now. Now, you will notice that this cell looks slightly different from the cell above, and I'll talk about the differences later on. But notice how it has in colon to it that says this is input. In fact, when we have this thing towards the left, what indicates is that this is not being treated as the text input we had here. And I'll tell you the difference in a second. So whatever code happens in these cells that has into it will be passed on to Python as opposed to being processed as text. So now what I'm writing here is simply saying, okay, I want to use Python to load some kind of library or toolkit called SymPy. Think of it as running to the garage and getting a box of different sized screwdrivers. Okay, what I'm saying is just to take all the screwdrivers from this toolbox. That's all it is. And then the next line says, I'm going to create a particular symbol called X. Right? So now whenever Python sees X, it knows it's not a number. It knows that it's being treated as a particular symbol. And then I'm just going to take a derivative, just going to differentiate the function of x raised to the power of 2, which is like this here, right? And then minus 4. And I'm taking derivative of this function, exactly like this, with respect to x. Now let me run this cell and see what it does, shall we? What do you think is going to happen? Well, let me run that. It'll take a second to run. And then the output of the cell is 2x. Magic. It's exactly the derivative we would have gotten by hand. You see, what we've done here is I've used SymPy, which is the toolkit that contains a particular function called differentiate that can help us take derivative of functions. And this function is very useful as we go through different practices and different questions within this course. And similarly, we can do more with SymPy because it can take differentiations. At the same time, it can solve equations as well. Not very complicated equations, but very reasonably simpler ones. We can solve a particular equation. For instance, we can solve what is the x that solves the equation that this function is equal to 0, right? So at what value of x is this expression equal to 0? So I can solve for that. Now notice there is no in here. This is saying this is actually a text cell. And I'm just using, again, the double dollar signs to wrap around the text that I want to render as an equation. So now if I run this particular cell, it's going to render the text. Okay. Now we're on to the next cell, where I just typed solve this particular equation of x squared minus 4, and I'm solving for x. Okay. We will talk about the details later on about how to indicate that this is actually an equation we want to solve, etc., etc. But for now, just see that the program will solve it for us. Magically, what it says is, well, it found two roots or two solutions to this equation, where x is equal to minus 2 or positive 2. Either way, this equation is going to be 0. Here we go. That's it. And this is really why we would like to use Jupyter Notebook for this course, because it allows us to present our work in a very nice way and share among ourselves. It makes it easier to submit homeworks, to edit them, to collaborate with your teammates, your peers, and also we can now borrow from these powerful tools to help us verify the work and ease our burden on the algebra front when necessary. And hopefully what we've done here illustrated that this is not something scary at all. So you don't have to be afraid, even if you had no programming experience at all. Okay. What happened above in these cells is, in fact, it involved 2 to 3 different programming languages. Okay. But what is a programming language after all? Well, I think a simple way to think about it for our purposes is just to think of each programming language as a different machine. So if you think about any machine you have, it just reads different inputs and then interpret them differently and perform different tasks. For instance, a microwave would interpret a particular dial differently than your car would. Maybe in a car, if I dial a particular knob, it's going to turn the lights on, whereas on the microwave, if I turn some dial, it's going to add a few minutes to the thing I'm trying to microwave. So they're going to take different inputs, and they're going to interpret similar inputs differently. Very much the same. Different programming languages are just different machines. They read different inputs slightly differently and interpret them into different things. For instance, in these cells above, we have some cells that are treated as text. So when you pass these cells to the computer, they are being rendered into text. Whereas there are some other inputs that are being read as things to do, things to calculate, and they are being sent to Python and being calculated and returned as algebraic results. The unique advantage of the Jupyter Notebook is it blends the text languages very well with the computational languages, which is the algebraic part that we need. In particular, Jupyter Notebook blends Markdown that is being used to render text with Python. So what is Markdown? Well, Markdown is just a particular programming language that's used to produce very pretty texts. It's very popular among web publishing. So if you write blogs, etc., many places will accept Markdown. Some writers like to use Markdown because it's really easy to use, although it seems really scrappy in the beginning, or it doesn't look as fancy as Word. But it turns out typesetting things, choosing what you want to write, and then sort of formatting them is relatively easy and also distraction-free when you use Markdown. And a particularly nice thing about Markdown is that it incorporates some functionalities of what's called LaTeX. And this is a different typesetting language, but it's specifically built for math. So for instance, if you want to write a lot of mathematical expressions within our text, using LaTeX is really convenient once you understood the basics of it. So it looks really scary, but in fact, it's not that bad. Okay. If you've ever tried to type mathematical expressions in Microsoft Word, you would understand it's very challenging. You have to click through each and every symbol almost every step of the way, and then the symbols will jump up and down from your texts and runs around as an image. It's really a struggle to work with. If you only do 1 or 2 of those throughout the entire course, I think you can get away with it. But for our purposes, you have to type a lot of those. So it's almost essential that you learn some LaTeX, especially later on in your career as an econ major. You will realize there are a lot of places where you need to type a lot of math. And in those cases, knowing LaTeX is a very useful skill. So might as well just learn to use it from this point onwards. And typing LaTeX is easy. So in fact, I just need to write f of x is equal to x raised to the power of 2 minus 4 and tell Markdown that this is a LaTeX equation. And that's it. So it's not bad at all. All right, so that is Markdown. That handles the text part in our notebooks. And then there's the Python part that handles the calculation pieces, where we actually need to use toolkits that sort of simplifies algebraic work we have. You can think of Python as a Walmart. It's just a very large collection of all kinds of different things, many different toolkits you can use for different purposes to complete different tasks. For instance, I can get toilet papers from Walmart. I can get fishing rods from Walmart. I can get bicycles from Walmart. So if you have ever heard of Python, you will see a lot of people talk about a package or a toolkit called Pandas, and it's a useful tool, especially to handle big data processing or analytical purposes. And what we use is a lesser known package called SymPy, and it's sort of dedicated package that does symbolic calculations. And what it means is these values don't necessarily have to have values, but they're used as symbols, much like your algebra class or your calculus class. So because Jupyter Notebook uses both languages in a mixture, they have to figure out a way to sort of help the computer understand what kind of code are you using or are you putting into the system and how they should read it. Right? Just like when you read something to Google Translate, it's much more efficient if you tell Google Translate, are you reading Spanish or are you reading English or reading French, etc., etc. So in Jupyter Notebook, the way to help the computer understand whether you're typing text or are you typing Python codes is to distinguish the type of cells. And in particular, it's these two types of cells that we care about the most. The first type is just called Markdown, and this is the part that handles text. And there are some other codes, some other cells that are handled as Python codes. And if you use R, it's going to be handled as R code. But here we have a Python engine running. So the code will be Python code and being read by Python engine and then processed like that. So whenever I type something in each cell, the computer reads it and interprets the code. If it is a markdown cell, it will be rendered into text. If it is a code cell, then it will be sent to a Python engine, and then the output will be returned. And this is exactly what happened here. If I double tap on the cell, you see that it returns to the editing mode. And you will notice that this little drop-down menu here shows this cell is Markdown. I can reselect this. I can say this is code, but then I won't be able to execute it through Python because the Python engine is just going to say, I don't understand what the heck is going on here. Okay, so I will just do Markdown, and then the in part will be gone, indicating this is just being treated as text. Now, if I run it, it's being rendered into text. And here, once I click on this cell, you notice that the type of this cell is currently code. This is why Jupyter Notebook is going to send this piece of code to Python to be interpreted and then being calculated later on. And this is a key difference between the types of cells, and we should be careful about that as we work on things. The specific rules of each programming language, Markdowns, LaTeX, or Python, are called syntax. And the syntax in Markdown is different from that in Python, but don't worry too much about it. I very much learn all of this stuff just by doing it. So as we go through the course, you will realize that all the necessary pieces will come together. And always, if you don't know how to do something, Google and ask. Do these two things. Google around a little bit. There are a lot of people posting solutions online on all kinds of different challenges and issues they had. And also ask your peers, ask the TAs, ask me about questions you might have.